I don't have any drinks, sorry. I don't know what's happening. Can you hear me?
Yes.
Great. Most experts agree that 1 is a number. Hands up if you agree with them. Show of hands.
Not an expert.
All right, most of you. That's good. We're off to a good start. Hello, my name is David Carlin. Today I'm going to be talking about refactoring Ruby. I work for Culture, the world's leading employee feedback and action platform. Also a great employer, so come and work for us. I have a label on my chest that says second best talk tonight. Thank you, Ryan. This is a lot to live up to. I've been working as a developer for over 15 years, and that is a very long time. It doesn't mean that I know everything. It just means that I am old. And I've seen a lot of stuff. And by the show of hands earlier, you could say that I've done a number of talks at this meetup before. I have a number of hobbies that look somewhat cooler in photos than they are in real life, and I sometimes make videos with puppets. But that's not why you're here. No, I know why you're here. You're here for the free beer and pizza. But beyond that, you're here for relevant Ruby rants. And that's a good thing, because there's going to be some good ones tonight. Some doozies. All right, a while ago, I was interviewing someone at Culture, and she said something very interesting. She said she wasn't very good at programming in the small, but she was really good at programming the large. What does that mean? It means she's not the best at stringing together lines of code to solve a problem, but she's really good at thinking about architecture and system solutions and how these systems work together. And this crystallized an idea for me that's sort of been bouncing around in my head for a while. And I think it deserves further exploration. I think that there are even more levels of granularity. So I tried to flesh it out. This is what I came up with. Line by line, just using the language to do something. Algorithms, splitting up a bigger problem into a series of steps that you can do easily in the language. Organizing code into methods, organizing code into classes, and organizing systems, things like microservices and all that. Now, when you start learning code, you sort of focus on number 1, and eventually you do number 2. And for most people, that's kind of where you stop learning. I mean, sure, I know, you make methods, you make classes. I know you're thinking that. I make methods, I make classes. But do you ever really spend a lot of time thinking about what the best way is to do that? I know every few years you go for a job interview and you reel out the solid principles and you talk about inversion of control and someone's substitution principle, list someone. Anyway, you study that before the interview. But no one really knows what those things mean, right? No one uses them day to day. Well, I'm here because I believe that the thing that will make you the best, will help you improve the most as an engineer, is number 3 and 4 in this list. Learning how to organize code into methods and classes better. And so that's what I'm going to focus on tonight. Refactoring. What is refactoring? I believe refactoring is taking code that already does something and without changing that behavior, modifying the code in some way to improve it. And maybe you make it easier to debug, maybe you make it more readable, maybe you make it easier to handle future requirements. Maybe you do all 3 of those things. Now, there are no rules to refactoring, no recipe that you can follow. So I tried to make one. So this is what I came up with. We'll see how it goes. Avoid nesting where possible. Split into smaller methods. Look for classes to split out. Avoid mutating state. Be very careful when you do. And be kind to yourself and each other. So we're going to try to apply this recipe to some code tonight and see how it goes, and we'll see if it's a good recipe or not. But first, let's take a little detour. I got another audience question for you. By show of hands, who here remembers their dreams? All right. So keep your hand up if you have recurring dreams. All right. Thank you. Okay, so I have a recurring dream, and it's kind of weird. It's kind of embarrassing. but I can tell that you're a trustworthy audience. I feel very safe up here, very supported, and if that's okay with all of you, I'd like to share it with you tonight. Every night, I have the same dream, that I'm playing tennis against the one, the only Ryan Big. Every night, every single night. And in these dreams, it's very hard to keep score of who's winning. And it just feels like Ryan's winning all the time because he's so good at everything he does. But I want to be sure. So I wrote a program to help me keep score. This is it. It's beautiful, isn't it? I know what you're thinking. You're thinking, this is perfect. There's no way that we can improve this. And maybe you're right. But seeing this is the talk of refactoring, we should probably try. All right, so first rule, always have tests. You have to make sure you have good tests. Testing is a large topic in itself. Michael Malevsky could probably talk for many Ruby meetups just about testing, and it would be wonderful to some. Sorry, I've gone off script here. But to refactor with confidence, you need to know if you're breaking any functionality. A big part of the definition of refactoring is without changing the behavior. And so good tests give you that confidence that you're not changing the behavior. So I don't have good tests, but I do have some tests. They call a method and they pass in some arguments and we check the results. So they should be good enough for tonight. All right, let's look at this. Look at this code. It's kind of long. It's pretty long for a method, right? It's doing a lot of stuff. Single responsibility principle says that each method should really only do one thing. And this looks like it's doing a lot of things. So we're probably going to want to split this apart into many smaller methods. And we've got to put those methods somewhere. We'll put them into a class. So before we do anything, just put this whole method into a class. Now, when you create a class, you've got three options. You can create a static method, you can create an instance method, or you can create an instance method where the parameters get passed into initialize method and then stored as instance variables. Now, I have a strong preference for the third type. It allows you to have private methods that work on those instance variables without you having to pass around parameters everywhere. And having state and objects can be a bit tricky at times if the state is changing, but for what we're doing, we're just going to keep the state exactly the same. Like the arguments that it gets initialized with, it's going to stay like that for the entire life cycle of that object. So let's do that. Let's split this out into a tennis class. We've got an initialize method that takes in the things. We've got a score method that I've kept deliberately small. We've got a couple of attributes down the bottom. Cool. All right, let's zoom in on that score method and see what we've got. All right, first rule is to avoid indentation where possible. Now we have this thing here, which does something, raises unknown player, scored a point, does something. Anyway, we could do that as a guard clause. So we could remove one level of indentation by returning early if something's wrong. All right, so that's good. We've removed one level of indentation. So what's next? What is this code even doing? Points minus player 1, player 2, not equal empty array. Scores player 1 minus scores player 2, greater than 2. It's almost like you need comments on each line of the code saying what the hell's going on. Now, when I was at university, that was a very long time ago, probably before most of you were born, but when I was at university, every coding assignment you did had to be fully commented, just every line commented. It was kind of the fashion at the time. It was probably for the sanity of the people marking our assignments. But we don't really do that anymore. It's kind of fallen out of fashion. Now, instead of commenting on what the code does, we only comment on the rare circumstance where why the code is doing something isn't obvious. So what do we do instead? We break down the code into small methods that each do one thing, and we give them very descriptive names. So let's try that. All right, this is a little bit better. If unknown player, if player 1 wins game. All right, this is almost readable. Almost readable, looking better. So let's have a quick look at all of these private methods that it's calling. So they're all simple one-line methods. They each do one thing. They have very descriptive names. They're pretty clear. But if we look a little bit closer, you might see something that smells a bit weird. Anyone notice anything weird about these? They all, well, not all of them, almost all of them take scores as a parameter. This usually implies that there's another object that you haven't surfaced yet. Something that works on just a single point of time in a game, like when Ryan's won 3 points and I've won 2 points. So we could sort of split these out into another object that does just that. Now, naming things is hard, but don't let that stop you from creating new objects. You can always change the name later. I'm going to call this object tennis point for now, which isn't a perfect name, but it'll do. So let's look at this tennis point thing. It takes in a score 1 and a score 2, and it provides all these lovely helper methods that tell us all about the game at that point in time. All right, let's see how we use this. So we create these 2 tennis point classes, objects, and then we just use them. This is a lot nicer because instead of passing scores into each of these methods, we just create an object and then we use the object. It encapsulates that logic into the object. The tennis point class, it only knows about the score values. It doesn't know about the player names. For now, we're keeping all of the presentation logic in the tennis class. All right, what now? So at this point, it's good to look for similar things. If you find similar things, you can usually abstract that out in some way. And so when I look at this, I see these lines. They all seem to be saying, return something if something. Like present something, present a score if some condition. We could extract these out into another object. They're all sort of presentation logic things. So we could create a score presenter. This makes this score method a little bit shorter, a little bit nicer. We just create a score presenter and we tell it to present. We pass in the scores and the names and we tell it to present. So let's take a look at this score presenter. Just takes in the point and the player names, checks all the conditions, and presents the score. All right, it's looking pretty nice. Now there's another couple of things we can do. Like we can create helper methods. So player 1 wins game or player 2 wins game. We can just say that's the same as game over. And we can start to extract out similar things, like score presenters used twice. We can put that in its own method. We can find tennis point is used twice. We can put that in its own method. But at this point, we're kind of just polishing the apple. Most of the major refactorings are done and we're just doing incremental changes. This code is far from perfect and we could keep going all night, but at some point you've got to stop and say, this is enough. Beyond here, the changes are just going to be incremental. So to summarize, what do we got? We've got this tennis class, which uses a tennis point to tell us information about that point of time in the game. And then we've got the score presenter that does the presenting of the scores. So this is almost like a model view and controller. The controller is the tennis class. It uses the tennis point model, and then it uses the score presenter as the view. Cool. Give me a yay if you're feeling it. Yeah. I love the energy in the room. All right, so let's do a quick recap. All right, refactoring. Avoid nesting where possible. Tick. Split into smaller methods. Tick. Look for classes to split out. Tick. Avoid mutating state. Be very careful when you do. Now, this is something we didn't talk about that much, but as you saw, when we pass in the arguments to the initialize method, they stay that for the entire cycle of the object, the entire lifetime of the object. And so this makes the class easy to test, easy to reason about, and just better, really. Yeah, better. I'd highly recommend you do this. Avoid mutating state wherever possible. And be kind to yourself and each other. Most of you have probably had the experience where you look at some old code from a project that you've been on and just like, who wrote this code? This is awful. It's just like the worst code I've ever seen. How does this person even get a job? And then you do a git blame, and of course your own name comes up. We've all had it happen. We've all had it happen. And I think this is a good thing. I think it sort of means that you're getting better. You're finding new and better ways to do things. And you're always going to be able to look back at the past and find a new and better way to do things. And that's going to be true into the future as well. So everything you write now that you think might be perfect, future you is going to look back and shake their head. So be kind to yourself because you're always somewhere on the journey, and so is every other engineer. So is this the end? I know the pizzas are here, but is this the end? Have we got to the end already? I know what you're thinking. You're thinking there's a big question I left unanswered in all of this. Who won the tennis?
Retro.
It was Ryan. Every night, Ryan wins. All right. Thank you, everyone.